On a cold morning in early 2025, the USS John F. Kennedy slipped its moorings at Newport News Shipbuilding and turned toward the open Atlantic. No fanfare, no speeches. Just a 100,000-ton warship beginning the most critical phase of its existence, builders' sea trials. The moment when 8 years of construction, billions in taxpayer investment, and hard lessons learned from its predecessor all converge into a single question: does it work? This isn't just another carrier going to sea. CVN-79 represents something the Navy has been chasing since the Ford-class program began over 2 decades ago. A second ship that proves the concept wasn't a fluke. The USS Gerald R. Ford broke new ground, but it also broke in ways no one anticipated. Kennedy carries the weight of those failures and the promise that this time, the systems are ready. This time, the technology is mature. This time, the Navy gets the warship it was promised. The stakes are higher than most realize, because if Kennedy succeeds where Ford struggled, it validates an entire generation of carrier technology. And if it doesn't, the Navy's plan to maintain 11 carrier strike groups in an era of great power competition begins to fracture. Builders' sea trials are where theory meets ocean. For roughly 2 weeks, Kennedy will operate in the waters off Virginia, pushing every system from idle to combat tempo. The ship's 2 Bechtel A-1B nuclear reactors will cycle through power levels that replicate everything from routine transit to flight operations under sustained threat. Those reactors feed 4 turbine generators producing over 600 megawatts, 3 times the output of a Nimitz-class carrier, and every watt matters when you're running electromagnetic catapults and advanced radar arrays simultaneously. The electromagnetic aircraft launch system gets tested first. EMALs replace steam catapults for a reason: smoother acceleration, less stress on airframes, ability to launch everything from heavy strike fighters to light drones with equal precision. But on Ford, EMALs became a symbol of technological overreach. Reliability fell below 400 launches between critical failures when the requirement was over 4,100. Kennedy's EMALs underwent 3 years of additional engineering: improved control software, redesigned power electronics, stronger linear induction motors. During trials, the crew will cycle through hundreds of launches using deadload sleds before any aircraft touches the deck. The data from each run feeds directly back to the system's predictive maintenance algorithms, identifying failure points before they cascade. Then there's the advanced arresting gear on the back end of the deck. AAG uses water turbines and electromagnetic motors instead of hydraulic fluid to catch landing aircraft. The advantage is precision, consistent deceleration regardless of aircraft weight or approach speed, which reduces fatigue on both airframes and pilots. The disadvantage, at least on Ford, was complexity. Hydraulic systems are brutal but predictable. AAG required software patches, component replacements, and operational workarounds that delayed Ford's combat certification by years. Kennedy's version incorporates all those fixes from day one. During sea trials, the ship will execute arrested landings in conditions ranging from calm seas to rough weather, testing whether the system can maintain recovery rates that match or exceed the Nimitz class. Power generation and distribution might sound mundane, but it's the backbone of everything Kennedy does differently. The integrated power system allows the ship to route electrical load dynamically. Need more power for EMALs during flight ops? Pull from propulsion? Need to charge directed energy weapons or run high-power electronic warfare suites? Redirect from other systems in real time. This flexibility is what makes Ford-class carriers viable in contested environments, where older ships would face hard choices between maneuverability and combat capability. Trials will stress test that flexibility under scenarios that simulate combat damage, system failures, and maximum sustained operations. The dual-band radar, sensor fusion networks, and combat systems get their own evaluation. Kennedy's SPY-3 and SPY-4 radars were designed to detect low observable threats at extended ranges while managing air traffic around the carrier. Unlike older ships where radar operators manually coordinated with flight control, Kennedy's systems are supposed to do it automatically, freeing up crew for higher-level decision-making. But automation only works if the algorithms can handle real-world chaos: multiple aircraft in the pattern, electronic countermeasures, weather interference, and sudden maneuvering by incoming bogies. Sea trials simulate all of it. The ship's damage control systems, fire suppression networks, and watertight integrity All face testing under conditions designed to find weaknesses. Because carriers don't operate alone, and they don't fight in pristine environments. They absorb hits and keep launching aircraft. Kennedy's design reduces vulnerability through zone isolation, containing damage before it spreads, and automated firefighting systems that respond faster than human crews. Those systems need to prove they work when compartments are flooded, power is lost, and the ship is maneuvering under stress. Crew integration matters more than most people realize. Kennedy operates with a crew of around 4,600, significantly fewer than Nimitz-class carriers, despite being a larger, more complex ship. That reduction comes from automation. Automated weapons elevators, automated cargo handling, reduced maintenance manning due to more reliable systems. But automation creates new failure modes. If a weapons elevator jams and there's no backup crew to manually haul ordnance, flight operations stop. Sea trials expose those gaps. The crew learns where the automation helps and where it hides problems until it's too late. What makes Kennedy different from Ford isn't just newer components, it's maturity. Ford was a developmental ship. Every system was first of its kind, installed while still being refined. Engineers were writing software patches while welders were closing hull plates. Kennedy benefited from watching Ford fail. When emails broke on Ford, engineers identified root causes, thermal management issues, power supply instability, software timing errors, and corrected them on Kennedy before the system was installed. When weapons elevators on Ford suffered mechanical failures due to design flaws in the rotating door mechanisms, Kennedy's elevators incorporated redesigned components from the start. This isn't just Navy spin. Independent assessments from the Government Accountability Office noted that Kennedy entered builders' trials with significantly higher system maturity than Ford at the same stage. Fewer critical deficiencies, higher completion rates on installed equipment, more stable software baselines. Ford taught expensive lessons. Kennedy is the proof those lessons were actually learned. The strategic context for why this matters cannot be overstated. The U.S. Navy operates under a force structure assessment that calls for 11 carrier strike groups to maintain global presence and respond to 2 major conflicts simultaneously. Right now, the fleet is aging. Nimitz-class carriers are being pushed beyond their design service lives. Ford, despite entering service in 2017, spent years in extended maintenance dealing with system failures instead of deploying. Kennedy arriving as a reliable, high-capability platform doesn't just add a hull, it shifts the calculus for how quickly the Navy can retire older carriers without hollowing out presence in the Pacific and Atlantic. China's naval expansion is not theoretical. The People's Liberation Army Navy operates 3 carriers now, with more under construction. Their shipbuilding capacity dwarfs American yards. While Chinese carriers lag behind in capability, they don't need to match Ford-class ships one for one. They need enough platforms to contest sea control in the Western Pacific, while America tries to maintain commitments in the Middle East, Europe, and the Indo-Pacific simultaneously. Every carrier that sits pierside due to maintenance issues or system failures is a gap China can exploit. Ford-class carriers were designed for this environment. Higher sortie generation rates, over 160 sorties per day sustained, with surge capacity above 200, mean more aircraft delivering more ordnance more often than Nimitz-class ships. Electromagnetic catapults enable higher operational tempo with less mechanical wear. Reduced crew requirements lower long-term operating costs, which matters when Congress appropriates budgets in an era of deficit spending and competing priorities. Advanced sensors and combat systems extend the defensive envelope, making the carrier more survivable against anti-ship missiles and unmanned threats that didn't exist when Nimitz-class ships were designed. But capability on paper is irrelevant if the ship can't maintain readiness. Ford's troubled introduction demonstrated that advanced technology without reliability is a liability, not an asset. Operational commanders can't build war plans around ships that might be available. Kennedy's sea trials are the proving ground for whether the Navy finally has a Ford-class carrier that delivers on the program's promises without the caveats. Success in these trials doesn't mean every system works perfectly. It means the ship meets objective performance thresholds across propulsion, aviation, combat systems, and survivability. It means deficiencies identified during trials are manageable, things that can be corrected during post-delivery maintenance without derailing the commissioning schedule. It means the crew demonstrates competence operating a ship unlike anything most of them have trained on before. Failure is more complicated. Minor deficiencies are expected. Major system failures that require redesign or extended repair push the commissioning timeline to the right, delaying Kennedy's entry into the deployable fleet. Worse, they raise questions about whether the fixes implemented after Ford's problems actually solved the underlying engineering challenges or just papered over symptoms. If Kennedy's emails or AAG or weapons elevators fail at rates comparable to early Ford systems, it validates critics who argue the Navy rushed to fielding before the technology was ready. And it creates political pressure on the Ford-class program that could affect future ships, CVN-80 Enterprise and CVN-81 Doris Miller, both under construction now. The Navy has been careful to set expectations. Officials emphasize that builders' trials are a test phase, not a victory lap. Kennedy will identify issues. Systems will underperform. Some components will need rework. That's the point. Better to find problems now, in controlled conditions off the Virginia coast, than during a deployment where failures have operational consequences. The real measure of success is whether the Navy and Newport News Shipbuilding can identify, correct, and verify fixes within the timeline needed to keep Kennedy on track for commissioning. Commissioning itself, likely in late 2025, is a ceremonial milestone. What matters operationally is when Kennedy achieves full operational capability, the point where the ship can deploy as part of a carrier strike group, conduct sustained combat operations, and integrate with joint force elements without restrictions. Ford took years longer than planned to reach that status. Kennedy needs to compress that timeline, not because the Navy wants to rush, but because the fleet needs capable hulls now, not in 5 years. Watching Kennedy steam out for trials is watching the Navy attempt to turn a corner. The Ford-class program has been defined by setbacks, cost overruns, and public skepticism about whether revolutionary technology was worth the risk. Kennedy is the first opportunity to prove that the investment is paying off, not in promises or projections, but in a functioning warship that can do what carriers have always done, project power from the sea, while adding capabilities that older ships can't match. This is the transition moment, when a new generation of carrier technology either proves itself or joins the long list of defense programs that looked brilliant in design reviews, but stumbled when confronted with operational reality. The ocean doesn't grade on a curve. Systems either work under stress or they don't. Crews either master complex ships or they struggle. And navies either maintain the capability to control sea lanes and project air power, or they watch rivals fill the vacuum. Kennedy's trials will run for weeks. The data will be analyzed for months. But the question being answered is simple and unforgiving. Is this the carrier the Navy needs, or just the one it could afford to build? The answer determines more than one ship's fate. It determines whether American naval aviation maintains its edge in an era when that edge is no longer assumed, but contested every day by adversaries who believe the era of American sea control is ending. The USS John F. Kennedy has begun trials. What happens next will echo across decades of naval strategy, industrial planning, and great power competition. Because in the end, carriers aren't just ships. They're statements about whether a nation can still build complex systems that work, maintain them when they break, and deploy them when required. Kennedy is that statement, sailing into the Atlantic under its own power, carrying the weight of expectations no ship should have to bear alone. But that's the nature of second chances. The margin for error is gone. The time for proving the concept has arrived.